Welcome to Get Preparation. Today we will solve question number 39 from Get 2022. The question is given as the major product P in the reaction sequence is, so here this nitrile oxide is treated with at first cis-2-butene followed by hydrogen ranitidine and then HCl and methanol water. So we have to determine the final structure of the product. Before moving to the solution part, let's have a look at the basic concept behind this question. So this is the structure of nitrile oxide, which can also exist as its resonance structure, this one. And now this nitrile oxides can undergo 1,3 dipolar cycloaddition. So if you see, this is like a dipole. So this is a negative part, and if you see this carbon, it can be, if you push this pi bond, you can see here on positive center could be generated. So you can say this is a 1,3 dipole. Now this can undergo a 1,3 dipolar cycloaddition with alkenes, and then we will get this isoxazoline product, and it can also undergo cycloaddition with alkyne, then we will get this isoxazole product. So how it can happen? So suppose if it is this O minus, if it attack on this alkene carbon center, now it can add on this carbon and this electron will move to the nitrogen. So we will get this isoxazole product. In the similar way, it can add to this alkene and we will give this isoxazoline product. Now if this alkene, so this is monosubstituted alkene and there is no question of any stereoselectivity. But if this alkene, you see here, this is cis alkene and this is trans alkene. Now if this cycloaddition happens, so what kind of product we will get? So if you see, in case of cis alkene, in our product also both this R1 and R2 are on the same side, are above the plane. So from cis alkene we are basically getting a syn product, and from this trans alkene we will get this trans product. So here also R1 and R2 are in trans relation, here also R1 and R2 are in trans position. So if it is cis, we will get syn. If it is trans, we will get this trans product. So with this basic information, let's move to the solution part. So now when this nitrile oxide is treated with this cis-2-butene, as we have seen, so we will get syn product. So both of this methyl are above the plane. Next, in presence of hydrogen and ranitidine, this nitrogen oxygen heteroatom bond can easily break and get hydrogenated. So if you break this bond and if you add hydrogen, what we will get? We will get here double bond NH. So from here we will get OH. So basically we are getting this compound. Here it is hydroxy and here it is imine. Now in presence of HCl and methanol water, imine can easily undergo hydrolysis and it will produce carbonyl group. So basically we will get this product. But now if you look at the options, you won't find that product as you have written in previous slide. So in all the places, if you see, this methyl group is written on the plane. So now we have to change this conformation such a way that methyl will come on the plane. So here on missing group is this hydrogen, so it will be below the plane. Now to bring this methyl on the plane, what we have to do? We have to rotate it, or this bond we can show. So if you rotate this and bring this methyl on the plane, you can see automatically this OH will come above the plane. So what we will get here? Ketone, and this is already above the plane. Now this methyl also we are going to present on the plane, and next, so this OH will come towards us, that means OH also will be above the plane, and now this hydrogen will remain below the plane. So this is the actual structure you can find in the options. So in our product, both this methyl and hydroxy are on the same side. So now if you look at the option A itself contain both methyl and OH on above the plane. So this is correct option. You see here it is in methyl is above, OH is below. It can't be the correct option. And here it doesn't contain any hydroxy. So this is also wrong. And here the imine is getting hydrogenated, that is also not possible. So this option also wrong. So option A is the correct option. Now to know more about this on 3-dipolar cycloaddition reactions, you can go through this NPTEL lecture video entitled on 3-dipolar cycloaddition reactions by Professor S. Shankara Raman, Department of Chemistry, IIT Madras. So here I have attached the YouTube link. Thank you for watching.